ready to go back to some sine, cosine, tangent stuff. We're going to pick up where we left off, 9.1b. We're going to review a little bit before we go on. So, we were talking about trig functions, right triangles, trig functions, and we had our fun word SOHCAHTOA. Remember, we had sine, which was opposite over hypotenuse. Cosine was adjacent over hypotenuse. Tangent was opposite over adjacent. And then we added on three new trig functions. Cosecant, which was hypotenuse over opposite. Secant, which was hypotenuse over adjacent. Cotangent was adjacent over opposite. Remember, all we had to do was take the reciprocal of those first three trig functions. So, to review, we are given these two ratios. The sine of some angle theta is 3 over 7, and the cotangent is 2 squared root of 10 over 3. We want to find the other four trig functions. So, first thing we're going to do is we're going to draw our right triangle. We're going to label one of the angles theta. So, if sine is opposite over hypotenuse, in this triangle relative to this angle, my opposite side is going to be 3. And my hypotenuse is going to be 7. Okay, so then cotangent, we were also given, cotangent was adjacent over opposite. So we already had the opposite side. We already had that one labeled as 3. But now I know my adjacent side is 2 square root of 10. So from those two trig functions, we can fill in all three sides. Now, we want the other four trig functions. So we want cosine, tangent, we'll want cosecant, and secant. And we can refer back to our original triangle. So this was the opposite side, this was the adjacent side, and this is my hypotenuse. So I know that cosine is adjacent over hypotenuse. So in this triangle right here, my adjacent side is 2 squared root of 10, my hypotenuse is 7. So I just write my ratio, 2 squared root of 10 over 7. Tangent, we know, is opposite over adjacent. So my opposite side is 3, my adjacent side is 2 squared root of 10. But we can't leave that radical in the denominator. So we could rationalize it, or since I know that these two are reciprocal functions, if I flip it, I get that, don't I? So I do have to do that anyway. We're going to multiply it by square root of 10 over square root of 10. So we get 3 times the square root of 10 over 2 times square root of 10 times the square root of 10 is 10, which is 3 square root of 10 over 20. And so that would be my tangent without any radical in the denominator. Now to get the cosecant and the secant, all we have to do is take the reciprocals. So we take 7 over 3, we'll take 7 over 2 square root of 10, and again, just like this tangent, we got to get rid of the radical in the denominator. So we're going to multiply it by a square root of 10 over square root of 10, which is going to give me 7 times the square root of 10 over, we multiply these two together, we get 20. And there's my other four trig functions from those first two. So that was what we did the last class. Now we're going to look at two specific right triangles. So a 45, 45, 90 right triangle. So we have the two acute angles are both 45. The relationship between these is the two legs are going to be exactly the same length. We call those both 1. And the hypotenuse is the square root of 2 times longer. Okay, we get that from, if I take x squared plus x squared, or 1 squared plus 1 squared equals c squared, that's where my square root of 2 comes from. The other special right triangle is a 30, 60, 90, and they are in this relationship. It's a 1 to square root of 3 to 2. So it goes in the order of the angles. So the shortest side is opposite the smallest angle, it's 1. Next biggest angle is 60, so that's my next longest side, square root of 3. And my right angle, 90, has the longest side of 2. Now, we are going to use these two special right triangles, and we're going to fill in the specific ratios for all 3 angles and all 6 trig functions so that we can solve to find unknowns for those special right triangles. So let's go back to our original SOHCAHTOA. I know what sine, cosine, tangent are, and then we can flip them to get our cosecant, secant, and cotangent. So sine, 30 degrees. Sine is opposite over hypotenuse. So the sine is going to be 1/2. Cosine of 30, cosine is adjacent over hypotenuse. So we get square root of 3 over 2. And tangent for 30 is opposite over adjacent. So I have 1 over the square root of 3. Now, we can't leave the radical in the denominator. So we multiply it by the square root of 3 over the square root of 3, which gives me the square root of 3 over 3. Okay? Cosecant, all I have to do is flip sine. So we get 2 over 1. Secant, I flip cosine. So I have 2 over the square root of 3. And again, we multiply it by square root of 3 over square root of 3 to get rid of the radical. So I have 2 square root of 3 over 3. There's my secant. And then cotangent is the reciprocal of tangent. If I take the reciprocal of this final one, I get a radical in the denominator. So I'm going to go back to the original, 1 over square root of 3. When I take the reciprocal of that, I get the square root of 3 over 1. No radical left in the denominator. So we've got all of our sine functions. We're going to do the 45. So 45 degree sine is opposite over hypotenuse. So 1 over the square root of 2. We multiply it by square root of 2 over square root of 2, which gives me the square root of 2 over 2. Now, funny thing for a 45 degree angle, the sine and the cosine are exactly the same, because if I take adjacent over hypotenuse, I get 1 over square root of 2, which is exactly the same thing. So I know this is going to be square root of 2 over 2. Tangent, 45 is opposite over adjacent. 1 over 1 is 1. So then cosecant and secant, if sine and cosine are the same, cosecant and secant are going to give me the same ratios. So I go back here, and I'm going to flip my original ratios. 1 over square root of 2, when I take the reciprocal of that, is going to be the square root of 2 over 1, which is just the square root of 2. And then cotangent is the reciprocal of tangent. The reciprocal of 1 is still just 1. 60 degrees, we got one more to do. We're almost done here. So, 60. Sine is opposite over hypotenuse. So I'm going to get the square root of 3 over 2. Now, the sine of 60 is the same thing as the cosine of 30. Those are called complementary angles. So if sine and cosine of 30 and 60 are the same, these two are going to be the same as well. The cosine of 60 is equal to the sine of 30. That's going to be 1/2. Now the tangent of 60, tangent is opposite over adjacent. So I get the square root of 3 over 1. It's the same thing that I had for the cotangent. If I take the reciprocal for cosecant, the reciprocal is sine, which is square root of 3 over 2. So I get 2 over the square root of 3, which is what we have right here. So I know this one's going to be 2 square root of 3 over 3. Secant is the reciprocal of cosine. The reciprocal of 1/2 is 2. And then cotangent is the reciprocal of tangent. So I'll have 1 over the square root of 3, which simplifies to the square root of 3 over 3. Now this is a table that you are going to want to refer back to often. Okay? We are actually going to use it in these next two problems. So, I have a 30, 60, 90 right triangle. For this 30-degree angle right here, this is going to be my adjacent side, and this is my hypotenuse. So we have to figure out which trig function we want to use if I have adjacent over hypotenuse. Which is, if we look back at our special word here, adjacent over hypotenuse is cosine. So, the cosine of 30 is equal to x over 16, adjacent over hypotenuse. Now, we already know what the value of the cosine of 30 is because we just found it in this table right here. So the cosine of 30 is equal to the square root of 3 over 2. So I'm going to replace cosine of 30, what we just said it was defined to be. Square root of 3 over 2 is equal to x over 16. I now have a fraction equal to a fraction. These, all we have to do are cross multiply and solve. So 2 times x is 2x equals 16 times the square root of 3. Just multiply there. To solve it for x, I divide that by 2. The 16 and the 2 cancel, so x is going to equal 8 times the square root of 3. That's going to be the length of the side. We got one more. Try this one again. Now this is a 45, 45, 90 triangle. So I'm going to use this 45-degree angle. Doesn't matter, I could use this top 45-degree angle. Either one will work. But for this angle, this would be my adjacent side, and this is my hypotenuse. So again, if I pick that angle to use, adjacent over hypotenuse means we're going to use the cosine. And the cosine of 45 is equal to my adjacent side, which is 20, over my hypotenuse, which is x. Now, the cosine of 45 cosine is equal to the square root of 2 over 2. So we are going to replace cosine of 45 with this fraction. Square root of 2 over 2 is equal to 20 over x. And again, fraction equal to a fraction. All we have to do is cross multiply these. So square root of 2 times x is equal to 40. If I divide that by the square root of 2, x is equal to 40 over square root of 2. However, we cannot leave that radical in the denominator. So, to get rid of it, we have to multiply it by a square root of 2 over square root of 2. We got to rationalize it. So I'm going to get 40 times the square root of 2 over, anytime I have the same thing underneath both radicals, the radical part goes away and we just are left with the 2. 40 over 2 simplifies to 20 times the square root of 2. And we have our value of x. So that would be the length of the hypotenuse. We have one more problem to do. Just a little review here. So on this one I'm given sine of theta is equal to 4 over 11. Okay, this is my angle theta. Here's my right triangle. So 4 over 11. Okay, we got to figure out the third side. So we're going to use Pythagorean theorem. 4x squared plus 4 squared equals 11 squared. X squared plus 16 equals 121. If I subtract 16 from both sides, x squared equals 105. And that is not going to simplify. So we would just leave this side as the square root of 105. So now that I know all three sides, we can fill in all of our ratios and find the other 5 trig functions. So cosine I know is adjacent over hypotenuse. So it'll be square root of 105 over 11. Tangent is opposite over adjacent. So 4 over the square root of 105. Now, if you've seen this pattern forming, I know whenever I have a radical in the denominator and I multiply top and bottom by that radical, I get the number times the radical over the number under the radical. Those are going to simplify. Now, cosecant, all I have to do is flip sine, so it's going to be 11 over 4. Secant, I flipped cosine, so I get 11 over square root of 105, which gives me 11 square root of 105 over 105. It's the same thing that we did right down here. And then cotangent, this last one, I'm going to come back to this original fraction and I flip it. So I get the square root of 105 over 4. There's my other 6 trig functions. I know, that was a lot of information in a little amount of time. Hopefully, kind of makes sense. And we got to review what we did in the last class. If you have questions, email me. Look forward to hearing from you. Bye.